Welcome back to another video. This is Algebra 2. I'm Mr. Hibble, and today we are looking at 3.1, rate of change. 3.1 has two sections. First thing, rate of change. Then we'll start to talk about graphing. When we're looking at rate of change, we're really only talking about quadratics at the point. We'll look at more what a quadratic is in the next video. Today is really just a discussion of average rate of change. So two things we need to know: what is rate of change and what is average rate of change? These are both ideas that we should have heard of by now. Rate of change is simply the idea of how fast or slowly a function increases or decreases. Increases just means how fast is your graph going up. Decreases just means how fast is your graph going down, right? It's how fast it's actually going. So how steep is your line versus how flat, or how fast does it go down, okay? That is rate of change. Average rate of change, though, average rate of change, though, they're just asking you, well, how fast or how slowly do you go up or down between 2 points? So all that's really asking you to do now is find the slope between those 2 points. Well, if we need to find slope, that's pretty nice because I could just use our slope formula. We know slope is m equals y2 minus y1 over x2 minus x1, right? And we've used that formula this year. You might see rate of change written differently than slope, but it's really the same thing. You might see it similar as maybe f of x2 minus f of x1 all over x2 minus x1. The x's, some people use a and b. That's what was in our notes. But I think these x's make more sense because you're still using the x values as your inputs. Realize y and f are really just the same thing on top of our fraction. They're just different notations. One is function notation and the other one's more of our standard xy notation. Let's look at some examples of how to utilize this. First thing, I want to find the slope. I want to find the average rate of change between -3, -1. A lot of people want to assume -3, -1 is a coordinate, but notice it's in these brackets. That's what's called interval notation. These two values are actually your two x values. Again, we tell that by the brackets. So knowing that, I need to figure out what are my two coordinates. I know one of them is -3 comma something and the other is -1 comma something, but I don't know the y values right now. Well, I'm going to use the x values to find them. So if I use the x value of -3, I go left 3. But now I need to know, okay, where is my graph during that section? And it looks like I do go down 5 points, meaning my y value is -5. Generally, you won't see me use those little swoops or whatever. I might just draw a line there and go straight up or down and start to count. For example, -1, go to where -1 is for your x. Count how far down you go or how far up you'd go to get to your graph. It looks like we would just go down a value of 1. That would mean my y value is -1. Once you have your x and your y for this should be pretty basic because now we're just plugging into our slope formula, which we had above, which was y2. My y2 value is -1. Minus y1, my y1 value is -5. All over x2 minus x1. Remember, big thing, don't forget to include the minus. And then if you have that minus and negative like we do on the insides here, the middles, then you could change that to a plus if you would like. You do not have to change it, but you could change it. Type that entire thing into our calculator, into Desmos, see what it gives us. If you were to type that in, you'd get a value of 2. Our graph goes up 2 coordinates for every 1 that it goes over. That is our slope, our rate of change of 2. This next one is where people get a little bit more confused. They say, okay, we know the 0 and the 4 are the x1 and x2, but now I don't have a graph, so how can I find my y values. Well, let's break this down a little bit. We know that we're given two different x values, and I know my function has some x's. Well, if you have a function and you have an x value, you can always plug in that x value. So I'm going to replace each of the x's in the function I was given with 0. So instead of x squared, I have 0 squared. Instead of minus 3x, I have minus 3 times 0, right? The x goes away, and now there's a 0 in its spot. From there, you could type that into your calculator, into Desmos, and get a value of negative 2. Well, realize what we just found. We used an x value, we inputted an x value, and we got out a value. So this negative 2 then is the output. Well, if you input an x and you get out a new value, that new value has to be your y value. This is y1. I can do that same process then with the 4. I can replace each of the x's with 4 and see what that is going to give us. So, okay, that's 4 squared and 3 times 4. Type that entire thing into your calculator, into Desmos, and I believe you get a value of 50. Well, again, we inputted an x value, so whatever we get out is a y value. Now we have our two coordinates. I know that one of my coordinates is 0, negative 2, and another coordinate is 4, 50, right? If you need to write those coordinates out, feel free to do so. And now just find your slope. Take y2 minus y1 over x2 minus x1 and get your final value of 13. Our graph goes up 13 units for every 1 unit that it goes over. So we've looked at how to find rate of change, or slope, basically, on a graph by finding the coordinates. We looked at how to find the rate of change from a function by plugging in. The last example would be from a table. And this, it doesn't have to be a word problem. It can work for any table. But I like this problem because it gives us an idea of what a word problem might look like too. So what it says is the table shows the number of students who took the ACT between 2011 and 2015. Find the average rate of change in the number of students taking the ACT from 2011 to 2015. Well, realize they're giving us our interval here. They're saying your interval, your x values, need to go from 2011 to 2015. So there's my x1 and my x2 on the table. Okay, well, if I'm given an x, that means the other value would have to be my output. It would have to be my y value. So these big numbers then are the y values. I don't care about the other coordinates in between this. I only care about the two coordinates that we are trying to find the rate of change between. So plug into your formula, y2 minus all over x2 minus x1, and figure out what that actual value is. If you type that one into Desmos, I believe it gives you like 75,000 or something. Let me double check it real quick. Yep, the value I end up getting is 75,331. Well, realize what we're saying then is this is the rate of change in the ACT students between 2011 and 2015. So the rate of change is telling you how many students the test increased by each year. So what we know is this is how many students, more students, took the ACT each year, right? This is what we're saying the increase was each year. It's the average increase each year between 2011 and 2015. that is our 3.1 video breaking down average rate of change. We'll come back next time and talk more about graphing quadratics and looking at their key features. Thanks for watching.